On August 21st, 2017, the Earth, the Moon, and the Sun are going to line up perfectly to create an incredible experience for people living in the United States. The shadow of the Moon will race across the country from Oregon to South Carolina, making a very narrow band for a total solar eclipse. People who will be sitting underneath that shadow will be able to see the Moon completely block out the Sun. But everyone in the United States will be able to experience at least a partial eclipse from wherever he or she might live. In order for a total solar eclipse to take place, a lot of factors have to line up perfectly. Let's take a moment to study the mechanics of an eclipse so that we can understand exactly what happens at that moment when the Moon gets in between the Earth and the Sun. This slide gives us a representation of our solar system. On the very left-hand side of the slide, you can see the Sun, and then the planets move out towards the right. Closest to the Sun is Mercury, then Venus, then Earth, then Mars. Those are what we call the terrestrial planets. They're rocky planets that you can actually stand on. After Mars, we have the asteroid belt, which is a collection of small rocks and minor planets that revolve around the Sun. And then outside of the asteroid belt, we have the gas giants, Jupiter, Saturn, Uranus, and Neptune. Jupiter is the largest planet in the solar system, and you can't actually stand on Jupiter. It's made up mostly of gas and some liquid, although there is probably a rocky core at its very center. Out beyond Neptune, you can see a small dot in this graphic that's marked as Pluto. Pluto used to be considered a planet like all the others, but we have discovered that there are many objects about the size of Pluto, some even larger, that are in our solar system far, far away beyond the Kuiper belt. Therefore, Pluto is now considered a minor planet. The largest object in our solar system is our own Sun, and it resides at the very center of the solar system. All of the planets orbit around the Sun, and it is the Sun that gives off so much energy that we can feel it as heat and we can see it as light wherever we might be in the solar system. In addition to the Sun, the other two important pieces of an eclipse puzzle are the Earth and the Moon. As you can see in this picture, the Earth's moon is actually pretty large in comparison to the size of the planet. Our moon is about 1/4 the size of Earth. Other planets also have moons, some of them a very large number of moons. But it's the relationship between the Earth and the Moon, of being exactly the right size and exactly the right distance apart, that makes a solar eclipse possible. I'm sure that you've all looked up into the sky and seen our moon, and I'm sure that you've all seen that our moon goes through phases. Sometimes the moon is very bright and perfectly round. Sometimes it'll look like a half circle, and sometimes you can't see the moon at all. When you can't see the moon at all, it's called a new moon. When you can see the right half of the moon halfway lit, it's called a first quarter moon. When you can see the moon nice and round and fully lit up, it's called a full moon. When you can see the left-hand side of the moon lit so that it looks like a half circle, it's called a third quarter moon. The reason that the moon takes on these different shapes at different times of the month is because the moon is orbiting the Earth. When the moon is closest to the sun side of the Earth, we can't see it in the sky because it rises at sunrise and it sets at sunset, and the side of the moon that we could be able to see is in a shadow. When the moon is on the opposite side of the Earth from the sun, then the side that we see is fully lit up. We see a nice bright round circle, and we call that a full moon. A full moon will always rise at sunset and will always set at sunrise because the full moon is in the opposite side of the sky from the sun. During the period of the month when the moon is off to the side of the Earth in comparison to the direction of the light coming from the sun, then from Earth we will only see 1/2 of the moon lit up. That will be either a first quarter or a third quarter moon. In this graphic, when the moon is at position number 1, it will appear dark in our sky, and that is a new moon. If the moon is at position number 5, then the moon will be fully lit, and that would be a full moon. If the moon were at position 3, it would be a first quarter moon because from the Earth, the right side of the moon would appear lit. And if the moon were at position 7, then the left-hand side of the moon would look bright, and that would be a third quarter moon. Looking from outer space, this is what the Earth, the moon, and the sun would look like at the time of a new moon. The moon is on the sun side of the Earth. It will appear dark to people on the Earth. It will rise at sunrise, and it will set at sunset. If you were in a spaceship out near our sun and you were looking back towards the Earth, this is what the Earth and moon would look like during a new moon. Notice that the moon is passing in front of the Earth. This is another picture of what the Earth, moon, and sun would look like at the point of a new moon. Notice that the moon is in between the sun and the Earth. But because the moon is solid, like any other object, it will cast a shadow. That shadow coming from the right-hand side of the moon and hitting the Earth is what creates an eclipse. If you were standing in that shadow on the Earth, looking up at the moon, then all you would see is darkness. Now, if an eclipse were that simple, we would have a total solar eclipse every single month when we had a new moon. But it doesn't work that way, and there are a few reasons why. One reason why we don't have solar eclipses every single month is because the moon does not orbit the Earth on the same plane that the Earth orbits the sun. Compared to the orbital path of the Earth around the sun, the moon's orbit around the Earth is tilted by 5 degrees. If we were to draw a line from the center of the sun through the center of the Earth, then what we would see is that the orbital path of the moon does not always fall on that line. Sometimes, because of the 5-degree tilt in the orbit of the moon will be above that line. Sometimes the moon will be below that line. When the moon crosses that line, it's called a lunar node. To understand this picture, imagine that the sun is far off to the left of the picture and out of the frame. The horizontal line that you see going through the Earth is actually the line that connects the center of the sun with the center of the Earth. Also notice that the moon is in a position in the sky in between the Earth and the sun. That means this is a new moon. But because the moon's orbit is tilted by 5 degrees, during this new moon, the moon is too high above the orbital plane of the Earth around the sun, and the shadow that it casts completely misses the Earth. There can be no eclipse at this time. This picture is very similar to the previous one. Imagine that the sun is off to the left, and you'll see that the moon is in between the Earth and the sun. This is also a new moon. But in this case, the moon is at a period in its orbit where it falls below the line that connects the sun to the Earth, and therefore the shadow that it casts again misses the Earth. You cannot have a solar eclipse during this new moon. And therefore, even though we have full moons and new moons every single month, most of the time the moon does not line up perfectly in between the Earth and the sun to create a solar eclipse. A solar eclipse can only happen when the new moon occurs exactly when the moon is either at its ascending or descending node. In other words, it can only happen when the moon gets exactly between the sun and the Earth at exactly the right point in its 5-degree tilted orbit. When that happens, the shadow that is cast by the moon coming from the sun can hit the Earth. Anyone who's standing on the Earth in the path of that shadow will in fact see that the sun is partially or totally obscured. Scientists have done a very good job of calculating out all of the geometry involved in a solar eclipse. We now know that it is theoretically possible to have as many as 5 solar eclipses in any given year. That would be very, very rare, however, because the moon's orbit just doesn't line up enough times to create solar eclipses that often. There's another point, however. Even if the moon were in exactly the right part of the sky to make an eclipse, it still might not be total. There's another bit of geometry to consider. As it turns out, the moon's orbit around the Earth is not an exact circle. It actually is more of an ellipse, which means sometimes the moon is closer to the Earth and sometimes the moon is further away. If the moon were always much closer to the Earth, then it would look much larger in our sky and it would completely blot out the sun. It would also blot out many of the most interesting features of a total solar eclipse. If the moon were a little further away, then it would look much smaller in our sky. And therefore, although it would block out part of the sun, it wouldn't be large enough to block out the entire sun. In this slide, you can see what happens when the eclipse takes place at a point in the moon's orbit where the moon is just a little bit further away from the Earth. The moon still does cast a shadow, but because the moon is further away and looks smaller in the sky, the shadow doesn't quite reach the Earth. When this happens, you will definitely still see the moon moving in front of the sun, but you'll still see part of the sun. This kind of event would be known as an annular eclipse, and it will make the sun look like a bright ring in the sky. It definitely would be neat to see an annular eclipse, but still the sun would be so bright that you could not look at it without an appropriate filter, and you would miss some of the most amazing aspects of a total solar eclipse. When things work out just right, and the moon is not too close and not too far, when the moon is not too high or too low, but when it takes its position just perfectly in between the Earth and the sun, at just the right distance, at just the right time, then we have a magnificent total solar eclipse. Before we describe what to look for during an eclipse, however, let's talk just a little bit about some eclipse history. Of course, human beings have known about eclipses and have seen eclipses for thousands and thousands of years. Before we understood how an eclipse worked, an eclipse could be a very frightening event. The Mayans, for instance, spent a lot of energy building very complex astronomical observatories, and they were able to incorporate lunar eclipses, solar eclipses, equinoxes, solstices into their religious practices. The Mayans became very, very good astronomical observers, and they were able to predict eclipses within days of their actual occurrence. As far back as 2,200 years ago, the Greeks were able to determine that the moon actually changed its speed during its orbit. At periods of the elliptical orbit where the moon is much closer to the Earth, it moves faster. At periods of its orbit, where the moon is further from the Earth, it moves more slowly. By understanding and being able to measure these changes in momentum, the Greeks were able to predict eclipses within hours. About 100 years later, the Chinese made similar observations, and they too were able to develop calendars that were capable of predicting the occurrence of solar eclipses. But of all the eclipses that have taken place during human history, perhaps the most scientifically important one took place in 1919 because it gave scientists the ability to test Albert Einstein's general theory of relativity. According to Einstein's general theory of relativity, very massive objects actually bend space. Space-time cannot be considered truly flat. In fact, gravity works because the space around a massive object actually gets bent by the mass of that object, so that another object moving in a straight line will actually, from an outside perspective, appear to curve as it follows the curve in space itself. I know that this idea is very complicated, and I'm sure your teacher can explain it in a little more depth. but the theory that space itself could be warped creates some interesting possibilities for observing changes in how the universe looks according to the theory of general relativity. Einstein's theory of general relativity predicted that space would be bent by massive objects, and Einstein did the complicated math to figure out just exactly how much the space around our sun would be bent because of the mass of our sun. Einstein calculated that a star that appears in our sky very close to the sun actually could look as though it's in a different place than where it actually is. The reason that it would look like it's in a different place than it actually is because the path that the light takes would actually be bent around our sun. Now that path of light would have to be very, very close to our sun in order for us to observe what is called gravitational lensing. The problem with measuring this gravitational lensing is that the light's path will only be bent very close to the sun, and the sun is so bright that it would be impossible to see the star that is behind the sun. However, a perfect solar eclipse gives us the perfect opportunity to measure gravitational lensing. During a total solar eclipse, the sun actually gets so dark and the sky gets so dark that it's possible to see stars, even stars that are very, very close in our line of sight to the sun. In 1919, a number of scientific teams spread out around the world because they did not want to miss this solar eclipse because of bad weather, and they actually measured the observed location of known stars close to the sun. What they found out was that Albert Einstein's prediction for the bending of light fit perfectly. This was a huge discovery. It confirmed Einstein's theory of general relativity, and Einstein became famous overnight. But enough about famous eclipses and eclipse geometry. Let's talk about what you're going to see when you see your eclipse on August the 21st. On August 21st, 2017, a total solar eclipse will pass right across the center of the United States. It'll begin in the northwest in Oregon, and it will end in the southeast in South Carolina. Maximum eclipse, that is the period of the longest duration of the eclipse, will be in Kentucky. Because the moon's shadow will be racing across the country at very high speeds, everybody's going to see the eclipse at a different time. In Lynchburg, first contact, which is when the moon first begins to cover the sun, will take place at 14 minutes after 1 o'clock in the afternoon. Maximum eclipse, where 88.6% of the sun will be covered, will take place at 41 minutes after 2 in the afternoon. And the entire eclipse will end at 2 minutes after 4. In order to enjoy the eclipse, you're going to need some special equipment. It is very dangerous to look directly at the sun, and it can cause serious damage to your eyes. So even during phases where most of the sun is blotted out by the moon, you must not look at the sun without wearing appropriate eclipse glasses. It is also unsafe to look at the sun through a telescope, binoculars, or even your camera unless that equipment is protected by special solar filters. Do not look at the sun with your naked eye. Do not look through a telescope. Do not look through your camera unless you have very special safety equipment. With the right kind of equipment, however, looking at the eclipse could be very beautiful. Check with your teachers to see if you can get your hands on some eclipse glasses so that you can just look up at the sun with your regular eyes. You may also be able to find some special solar binoculars or telescopes with the right kind of filters in place so that you can look at the partial phases of the eclipse. But again, do not use regular binoculars or a telescope without the right kind of filter to look at the eclipse. You need to have special equipment to be safe. Your teacher can help you find the right equipment. The only time that it's safe to look at an eclipse without any special equipment is during totality, when the moon completely blots out the sun, and you can look up and see special features that cannot be seen at any other time. But that is only during totality. So if you are not in a place that will experience a total solar eclipse, you need to use your special equipment throughout the entire partial eclipse. If you are lucky enough to be in a place where you can watch the total solar eclipse, then these are all the phases that you will see. Starting on the left, you see first contact, when the first bite of the sun is taken out by the moon. The partial eclipse is the next frame, where a good portion of the sun is obscured by the moon. Just before totality, we see a bright light at the lower left, and then we are in totality. In this place, we can take off our eclipse glasses, we can take off the filters on our telescopes, and we can marvel at the total solar eclipse. But it only lasts for a couple of minutes. And then another bright light shines on the other side of the moon, and we know that totality is over. The moon slowly begins to retreat away from the sun's disk, and we have a final end to the eclipse on the right-hand side of this slide. So to review, in Lynchburg, the eclipse will begin at 1:14 in the afternoon. It will reach its maximum phase at 2:41 in the afternoon, when 88.6% of the sun will be covered. It will then come to an end at 4:02 in the afternoon. This is another composite image showing the different stages of an eclipse. In summary, there are 4 distinct phases of an eclipse. First contact is when the moon first begins to eclipse a little piece of the sun. Second contact, which will only take place in areas directly under the shadow of the moon, is the beginning of totality, when the sun's surface is completely blotted out by the moon. Third contact is when the moon begins to move off and a little bit of the sun begins to show through at the edge. And fourth contact is when the last little bit of the moon's shadow can no longer be seen and the eclipse is over. Even if you don't happen to be in the path of totality, there are some really interesting things to look for during an eclipse. For most of the eclipse, the most interesting thing to see will be the shape of the sun itself, as the moon slowly moves across, creating a larger and larger eclipse. If you have the right kind of equipment, you might even be able to see the sun up close and take a look at sunspots. In sections of the country where the eclipse becomes quite significant, the sky will actually grow pretty dark. We'll see crescent-shaped shadows, a 360-degree sunset, and animals and birds will begin returning to the nest, the hive, or the den because they think it's becoming nighttime. This is an actual photo of a partial eclipse where you can see that the sun actually takes on a crescent shape caused by the moon moving in front of it. In this photo, you can see the funny shape that shadows make because of the crescent shape of the sun. You could have some fun by poking holes in a piece of paper and creating basically a pinhole camera projecting this crescent-shaped shadow. It would be easy to spell out a word or your name with holes in a piece of paper and take a photo of your own special eclipse signature. Now, if you happen to be in a place where there will be a total solar eclipse, you even have more to look forward to. Just before totality, the last rays of the sun will just be skimming along the edge of the moon. And the moon is not a flat surface. It has mountains and valleys. So the mountains will begin to get in the way of some of the sun's light, and some of that light will pass through those valleys. This broken ring of light around the edge of the moon is known as Bailey's beads. Bailey's beads will only last for a few moments, and they'll begin to disappear one by one, but the light of the moon will then be concentrated in one particular spot. Just before totality, the last of Bailey's beads will appear very, very bright. It will just be at one point on the edge of the eclipse, and someone is bound to scream out, "Diamond ring!" This is the moment when totality begins, and it is safe to take off our eclipse glasses. Once totality begins, it is safe to take off our eclipse glasses, and the sun will look like a black hole in the sky. It is a very strange experience, but as our eyes begin to adjust to the darkness, other very beautiful and very interesting observations can be made. Although the main portion of the solar disk will now be obscured by the moon, the outer portions of the sun's atmosphere will become visible. This is the only time that the human eye is capable of seeing the beautiful solar corona. With the right kinds of telescopes, it's also possible to take a closer look at the sun. The sun is not a stable and quiet place. Very often the sun has streamers of fire coming off its edges called prominences, and during a total solar eclipse, when the brightest part of the sun's light is no longer in view, those prominences become visible. But after just a couple of minutes of totality, we're back to a partial eclipse. After a second diamond ring, it'll be time to put our eclipse glasses back on and watch the moon retreat from the face of the sun. And now, the only thing left to do is start planning for the next solar eclipse in the United States in 2024. If you weren't able to make it to totality this time, hopefully you now know enough that you'll want to get there in 2024.